Good morning, everyone. It's a great pleasure to welcome to the stage a colleague of mine from for some years now, to introduce our first keynote speaker. So I'm doing an introduction of the person doing the introduction, if I may, just briefly. Gabriella Waters was at CEAMLS when I got to CEAMLS 3 years ago. She was foundational to its foundation. She's part of the DNA of the organization, and she's worked closely with our first keynote speaker. So I thought I would ask her to come up and do the introduction. Please welcome Gabriella.
Thank you. It's introduction inception. I am so happy to introduce Reva Schwartz. Reva and I had our cute meet at NIST in the AI Innovation Lab on the ARIA project. And it became very quickly apparent that she and I really cared more about the service that these models provide to people and how they show up for people than the benchmarks that were being held as the industry standard for what capabilities are. And so we continued that relationship and became co-founders of Civitaas, where we evaluate AI models and how they actually show up and are measured for the impacts they have in the real world with real people, not inside the lab or inside a box or really sterile situations. And so most of the time you see people read a bio. I live the bio with Reva. And so I'm more than honored to introduce Reva Schwartz as our keynote speaker at the third annual symposium for the Center for Equitable AI and Machine Learning Systems. Reva.
Thank you. Thank you. Good morning. Thank you so much. And what a nice surprise that is. My amazing colleague, Dr. Waters, who I didn't know if she was going to be here this morning, and then she's here and introduces me. So what a great way to start the weekend or the Sunday. All right. So my name is Reva Schwartz. I'm a research scientist and co-founder with Dr. Waters of Civitaas Insights. I want to start by thanking the organizing committee for inviting me to Keynote today and for all their work on putting on this symposium. I was here about 2 years ago. Glad to be back. And thank you all for being here relatively early on a Sunday morning. It's still Sunday. So my background is in linguistics and human language technology, and I've worked at the intersection of measurement, development of machine learning tools, and the socio-technical settings that these technologies get deployed into. And I've spent a lot of time back at NIST. NIST lives and breathes measurement and evaluation. I lived to breathe AI evaluation, even before it became the big field that it is today. And from where I sit, one question keeps getting overlooked, and Gabriella kind of alluded to that. And how much does the deployment setting matter to how these systems perform? And how do we actually measure that? And the question is more urgent now than ever because AI is not just in labs and tech companies anymore, it's everywhere. So today I want to talk about AI evaluation and about the deployment setting and why I think evaluation methods, why we think at Civitaas, these methods must take deployment setting more seriously. And not just to make models better, but to give people who deploy, adopt, and use these systems a different kind of evidence than what they have today. Because right now, that evidence is not fit for purpose. So let's walk through why. Maybe not. Oh. Just, sorry. Thank you. Thank you. So I want to start somewhere that has nothing to do with AI, and it's kind of a random story, but as a measurement scientist, I have always found this to be very instructive. So we're going to the 1980s. The rock band Van Halen had a writer in their touring contract, pages of technical specs, load limits, rigging, power draw, and buried in the middle of that contract was a demand for a bowl of M&Ms backstage with every brown M&M removed, really bizarre, right? And apparently, for years, this story got told as an example of rock star excess, but it wasn't. That bowl was a very elegant measurement instrument. The band could walk into any venue, check the bowl, just go straight back into their dressing room, and instantly know whether the venue had actually read the contract carefully. And if the brown M&Ms weren't in the bowl, they knew they were in for a lot of work because the venue had probably overlooked all sorts of other important things. This one small checkable signal stood in for the integrity of the entire setting. And notice what they weren't so worried about. They weren't checking whether the stage would hold, whether the power would stay on. Those are kind of the thin edges. The venues have that covered. What the bowl told the band was something different. Whether this specific venue on this specific night actually understood what it was hosting. And that's about the contents. This thing that, edge inspections don't really reach. So that distinction, thin edges versus contents, is going to make more sense in the next few minutes. So this slide shows a landscape of much of the current AI evaluation ecosystem, which is really designed for one purpose, to measure and optimize AI models. And there's a selection of methods up there: benchmarks, red teaming, evals, pilots, incident tracking. And some of these methods collect evidence from real deployment settings, some don't, but trace any of those arrows, and they all lead back to the same place, right? The stack, to mitigate, optimize, and improve the model. And that loop is real, and it obviously matters. We all want better performing systems, but it's the only loop we have right now. And if you're an organization, an institution, a community deciding whether to adopt or deploy AI, that loop doesn't tell you what you need to know. It gives you a promise that a better system is going to solve the problems. And there's a whole arc missing from this picture, and that arc is evidence flowing the other way towards the organization, towards people outside of the AI stack that is fit for purpose. So here's a way to picture what's actually happening in AI evaluation today. Now, this is just a basic container. It reflects the current way we approach the measurement of AI. These two thin edges represent what we currently account for. And I'm obviously summarizing here, there's a lot that happens, but for the most part, at the top edge, we measure whether the input is in bounds. Does the prompt look like something the system should handle? And at the bottom edge, we measure whether the output is in bounds. Did anything drift? Did it stay inside the guardrails? And that's what benchmarks do. It's what most evals do. It's what AI observability tooling does. And they watch the thin edges. And to be clear, that is not nothing. Knowing the edges are stable matters, and it keeps these systems inside their guardrails. And I'm not critiquing what we do now. I'm only saying that it isn't enough for everyone who works and lives outside the AI development stack. Because we also need evidence about what's inside that container. You can call it the zone of consequence, the whole space of what actually results from this system being deployed here, not what the system is capable of in principle. When people say AI is a socio-technical system, which we say often, this is what they actually, I'd like to think, refer to. This zone is the socio-technical part, and it's not being accounted for in our measurement paradigms. And this isn't about the user experience of the tool. That's a different question. And this is about the information itself and its quality, the language used in the domain, how meaning gets signaled in it, the institutional structure around it, roles, chains of command, incentives, what counts as routine versus consequential. And that is a pile of complexity, and all of it is full of variation and shifts over time. So today's evaluation ecosystem was absolutely never built for that kind of complexity, but machine learning systems constantly change based on these very external drivers. So it is not trivial. So the differentiator here is variation and how it's handled, because variation is omnipresent in deployment and on the model side. In deployment, you can think of variation as the water a fish swims in. It is everywhere, but so implicit, it goes unnoticed and unaccounted for in our measurement paradigms. On the model performance side, which is measured at those thin edges, variation is seen as a nuisance. When you want a system to be stable, variation means drift, noise, the thing you're watching for, so you can flag it and correct it back to the baseline. Inside the container, variation means something else entirely. It is not noise, it's actually signal. It's where the meaning is. It's how you figure out what needs to be done in your job, people who use the technology. So removing deployment-facing variation creates real challenges for and in deployment, making it difficult to tell a good outcome from a bad one. Here's a version of this most of you have already run into. Organizations are obviously really pushing staff to use AI more, but at the same time, there's a lot of concern about over-reliance on these tools. So it's really hard to figure out the actual line between reasonable and unreasonable reliance if you're only looking at those edges. And these deployment-facing questions can't be answered by testing the chatbot harder, more tech. It requires a very different type of evidence. And so what we really have here is a good old-fashioned measurement trade-off. We have a model optimization focus on one side and a deployment focus on the other. And one sees variation as noise, and the other sees it as a signal. So it's a trade-off that right now is keeping systems stable, but it comes with a cost. So picture a claims adjuster with files on their desk. They're not reading every word, they're scanning, and in a short period of time on each file, they already are able to figure something out. They know which one is routine, which one isn't, which one needs a second look. And domain experts can't really tell you exactly how they know. It's something that doesn't quite add up, something's off from the usual. That fast bottom line meaning is called gist. And it's more than reasoning through a document, it's the practical sense of what's actually going on. And they use that to organize their work in their domain and to take action. So gist lives in variation. And when it gets flattened, that adjuster loses the thing that they were actually trained to notice. And every domain has its version of this. Clinicians reading a chart, caseworkers reading a file, that scanning is their job. And that's what's at stake when variation disappears. And it happens at two levels. So the first level is what I've been mentioning, people using these systems in their daily work. When gist is removed for them, the output still looks fine. It's fluent, it looks complete. It may very well be accurate, but the signal an expert uses to notice, this one's different, I better pay attention to this. It's not there anymore. And if they catch it, they have to put it, somebody has to put it back. So they have to reread the source, double check the summary, second guess a system that gave them no reason on its face to be second guessed. And that is real work, and it's really frustrating, and it's showing up everywhere right now with AI. And people who actually use these tools day to day are often the only ones who notice it, and they can often not put their finger on it, much less label what's happening. They just know they don't like it. So that evidence doesn't show up anywhere else. It doesn't show up in a benchmark. It often doesn't even show up in what gets reported up the chain, because the people closest to the work are basically absorbing that cost pretty quietly just to get their job done. And this compounds, right? With a single generative output, you're recovering gist from one flattened summary, and an agentic system where one model's output becomes the next model's input across several steps. That flattening happens at every trade-off, at every handoff. By the time a person sees the result, they may have to recover the meaning from every step at once, if that's possible. So let me make that a little more concrete. Say you have an agentic system handling a customer service escalation, the same kind of practitioner moment we just talked about. Every step in that chain can pass a factual accuracy check. There are no hallucinations. Every claim is traceable back to the source. So if you evaluated it the way most evaluation paradigms are designed today, it's going to score great. because accuracy and traceability are exactly what today's evaluation approaches are built for. Accuracy isn't the only thing practitioners need, or any user of AI. They still have to act on AI outputs. They still, it is serving a purpose. And that action step is often extremely narrow, sometimes in the next 60 seconds, depending on the job, and sometimes with customers still on the line. So a response can be, a chatbot response can be completely accurate and still not provide utility in that moment. It can be the wrong length, the wrong register, missing the key details that change what the customer service representative sends next. So that's the gap. We have a whole evaluation apparatus built around accuracy and capabilities on benchmarks, and very few tools built to assess what it means in the deployment setting. And those are different questions right now. And those are different questions right now. We're not answering that second one. And that gap is slowing down AI adoption. So that's the user side level. The second level is about evaluation, which is what I really want to talk about. An evaluation deployment-facing variation gets reduced because testing requires a stable target. Evals and benchmarks test model performance and safety. They identify drift. They assess whether a system failed a known test case. And to create that stable foundation, variation has got to go, because you can't run a clean comparison across a moving target. So getting rid of deployment-facing variation is just what it takes to hold the model still long enough to score it. So the problem here, though, is our gist. What's happening to the signals that enable it? Well, they're getting erased. And nobody sets out to do this. But by focusing only on the thin edges of the container, gist becomes a casualty. And at the evaluation level, this means that organizations are left with numerous blind spots, just like practitioners have, only a couple layers up. So what organizations basically need is the equivalent of the M&M pool, not benchmark scores, drift reports, guardrail compliance, or other evidence describing the thin edges. They need the signals that actually tell them what's happening at the level of deployment. What signals are they not getting? Well, first, risk signals. When output looks complete and accurate, people are just going to proceed with it because there's no signal that anything's lost or missing. And if it's not being measured, it's not getting flagged. So using benchmarks as the key criteria for whether content gets pushed out means many things get missed. Another big signal is extra work. We talked about the fact that domain experts who recognize, or just anybody using AI recognize that something's off, may have to quietly rebuild what the system left out, or just, is it taking less time to use the AI than if we had done it our own? So that's real labor happening constantly, and it's invisible to any evidence the organization currently connects. It doesn't stop with staff. Customers also absorb some of that same cost when they're the ones left to catch what the system missed. There's also technical debt. Multiply that quiet reconstruction process across every practitioner, the cases in an org. Over time, you get workarounds, shadow processes, extra review steps, and none of this is planned and none of it's tracked. And so we hear about this a lot, about the amount of money that organizations are spending to keep AI working in their organizations. And so this means that there are decisions the organization can't make effectively. Say a legal aid organization rolls out an AI system to help intake staff draft first pass summaries of incoming case files. The goal is for attorneys to triage faster. So the org tracks adoption, usage climbs, the survey staff, the satisfaction scores are high. People love it. They use it constantly. Leadership sees a rollout that really looks like a clear win. And what that satisfaction score can't tell them is whether the summaries staff are happily using are actually driving better triage decisions out in the real world, right? What's the outcome? People like a tool because it's fast and easy, that's great, and it can still be making poor decisions with it. This ease of use and decision quality are obviously two very different metrics, very different constructs. And a tool can get adopted precisely because it removes friction, even when what it's smoothing over to move faster is the very judgment call someone used to have to slow down and make. So the org has high adoption, high satisfaction, and no evidence at all about whether the thing the tool exists for, what they bought it for, faster and better triage, is actually happening. And those are two separate questions, and only one of those got measured, and it's the one that's the easiest to collect. So that's the blind spot. It's not that people are wrong to like tools that make things easier and faster. It's that people use it and like it, and it does the job in this setting, got treated as the same construct when they're two different things, and only the first one ends up with any evidence behind it. Another decision that is top of mind for organizations right now is whether a workflow can be automated or when a person needs to steer it. Right now, that decision gets made on model capability alone because that's the only evidence available. And then there are decisions about the return on investment for AI deployments. And those require a measure of the value this deployment is actually providing once you account for the labor it took to compensate for what got left out, not just whether the rollout went smooth. So these costs obviously do not show up in a benchmark. Thank you. Thanks. Okay, so this is a pattern that shows up every time a technology reaches this scale. The web, search engine, social media, electronic health records, these advances get optimized first for speed, for scale, and for reach. And that optimization, like what's happening with AI right now, is about the components at the thin edges, making systems go faster, making them bigger, capabilities, and reliability. Figuring out what the technology is actually doing to people, to decisions, to institutions, communities, that always comes later. And it's usually built off to the side by people who have very little to do with building the technology itself. And so that sense-making phase hasn't really started yet. And it requires real evidence about what these tools actually mean for the people depending on them and impacted by them. And what's different this time, we say this all the time about every new advancement, is we don't have to actually wait decades. We have the tools and the methods to build both at once if we choose to. So if the optimization phase was built by computer scientists, engineers, and machine learning researchers, the sense-making phase doesn't make sense for that, right? We need a different disciplines. And understanding what a deployment setting demands requires people and experts who know how to read settings. Ethnographers, socio-technical researchers, domain experts, designers. It also requires people who know how to measure in context, not just whether a system performs, but whether it fits, whether it just survived the process, whether the system provides value in setting. And there are real signs that this change is starting to happen. From an evaluation standpoint, independent evaluation is gaining traction. And the argument that AI systems should be evaluated by parties that have no stake in the outcome is no longer a fringe idea. Participatory approaches are being written into policy frameworks, and the idea that affected communities should have a role in defining what good performance looks like instead of just researchers and developers is also showing up in regulatory guidance. But there's a risk in all that. Participation can get reduced to an extractive exercise. Independent testing can get captured by the same thin edge metrics that already exist. And the voices of practitioners and communities can get translated into proxies that don't actually carry what they were saying. The methodological challenge and the contribution of communities like here at the symposium is figuring out how to bring those voices in without substituting for them, how to build the measurement infrastructure that keeps the setting central, not as an input to model evaluation, but as the object of inquiry itself. So let's go back to that missing arc. All the evidence we generate today loops back to the stack, to optimization and the people building the system. Well, what if we flipped it? What would it look like if the evidence ecosystem were designed to flow forward to the organization also, we're not taking away evidence, to the organizations deploying these systems, the practitioners depending on them, and the communities who live with the consequences? It might look like evidence collected from inside that container, from the zone of consequence itself, not just at the thin edges. And evidence about what the setting required and whether that requirement was met. It would look like measurement tools that practitioners can actually use, not just dashboards built for data scientists and instruments calibrated to the workflow itself. It would also look like an accountability layer, not just investigating model output, but connecting that output to real world outcomes. So when something goes wrong, you can trace it. And when something goes right, you understand why and whether that good thing can take hold. So that's not really a research agenda. It's a set of institutional questions. In the same way we built infrastructure for food safety, financial auditing, and for clinical trial oversight, we need to be sure that the future institutional landscape for AI enables more than just measurement at the edges. And that infrastructure doesn't exist yet, but the methods to build it do, and the people who understand those methods are right here. So I just want to leave you with a reframe. Right now, almost every institution with a stake in AI is organized around the same assumption, that the path forward is better models, more accurate, more robust, more well-aligned. But even the best model still has to be made sense of once it's out in the real world. That doesn't go away. Better models don't make that go away. They just move things downstream. And we've seen how that plays out in almost every other industry. So if AI is going to be truly transformative, institutions need to aim the measurement of AI more broadly, not just at the model, but at the setting it lands in. And so that's what we mean by stepping outside the stack. It means starting with the setting before you reach for a benchmark, before you pick a metric, and before making decisions just based on model performance. It means bringing in the methods that know how to read a setting, like socio-technical analysis, ethnography. And it means measuring where it matters, not in the lab, in the place the system lands. And so if Van Halen checked a bowl of M&Ms and knew exactly everything they needed to know about the venue they'd never seen, we can build that same kind of easy signal for AI. And that's the work. I will leave it there. Thank you.
Thank you so much. Please join me in thanking again our speaker. Are there any questions for Reva Schwartz? So you talked a lot about the gist as something that was left out, but I know your work on AI evaluation beyond the stack is quite extensive. I wonder if you give us a picture of a couple other ways things can go wrong when we don't pay attention to those kind of out beyond the bench deployments.
Yeah, I mean, if you think about any risk, if we measure it inside the box, so to speak, with benchmarks, we get a preclinical view, if you will, of what actually happened, not where it happened. So that means we think a given risk is a big deal, and we measure it out in the real world and find out it isn't, that means we're spending a lot of time on things that may not matter. And of course, those risks change wherever you are. So everybody, chases hallucinations in one moment, and now over reliance is a big thing. Where are these things playing out? How big are those concerns? And conversely, if we're all paying attention to hallucinations and over reliance, maybe there's discrimination and harmful bias are still causing problems. How does that play out in the real world? So we have this kind of, in many ways, it's the attention economy. We're going to focus on risks that we have the latest benchmark for. But at the higher level, in which I got into with GIST, is that those benchmarks do not really provide meaning outside of the stack. You see people talk about a model's reasoning capabilities, but what does that mean, right? You see benchmarks about different types of behavior or styles of a model. What does that mean? What does it mean to me as a user? What does it mean for further up the chain? So it's a lot of it is about meaning making rather than building better models.
Any other questions?
Thanks for this presentation, Reva. Since we're at an academic institution, I feel like a good distinction would be to describe the difference between testing and evaluation, because we have a lot of students who are used to testing the systems that they have developed. But what is that distinction so that they can understand some of the other areas that they might need to look at? And then where does evaluation fit in that development life cycle?
Yeah, evaluation, which is different from research, and testing, which is different from validation. These are all different things. So if we're testing, especially a model, we want to see what is the model giving me, in this specific setting, that time. Evaluation, we're looking for a broader set of when some intervention was proposed, like the AI, what does it mean for the outcomes in that setting? So testing is, what's the output? Evaluation is a little more, what's the outcome?
Any other questions?
Hi, Dr. Schwartz. Thank you for your presentation. In the academic area, one of the big things that's going on now is how can teachers be helped to adopt the AI into the curriculum? Because there is mixed direction in many institutions as far as some say, of course, no AI. Obviously, when I was part-time teaching, we told them that you can use AI for your homework. However, you can use AI to learn about the topic. So there's a lot of gray area. Of course, this is a big question, but I just wanted to get your input as far as any thoughts on how institutions can help. And number two, how the teachers can adopt the technology in a practical way, because we all know, thanks to all the teachers and faculty members who sacrifice their time, they spend a lot of time outside of class prepping and doing, grading homework. That's a lot of person hours. Thank you.
Thank you. It's a great question, and it's an example of how benchmarks really can't answer those questions, right? So benchmarks can tell us, like, it's okay to put these systems into the classroom. We have our guardrails set up. You have governance rules, but we'd like to say, have you met people? Because people, the model's going to do things that you never anticipated the first time out of the box. That's that preclinical piece, right? Like, once people start taking the drug, different things happen. Once people start using systems in the classroom, but I want to also get at your point about how we say, well, AI is this amazing thing and everybody should use it, but wait, but don't use it here. And, when I looked at, I think it's UC Berkeley had recently come out with a set of practices for when you should, when it's good versus bad uses of AI. The problem is that none of these are evidence-backed. We just kind of, from an ethical standpoint, we recognize that it's bad to use AI in these settings. And so we set these broad guardrails, and I'm not saying we override ethics requirements. I'm saying we need evidence as well to back up genuinely where these lines are. And so I think for teachers, I think there's a lot of, just like with any machine learning tool, there's a lot of, uses for streamlining workflows and for taking some of the load off. But over time, what we find is that AI can sometimes make the workload harder, make the workload more. And so how do we track that? And we can't really track that with a benchmark. We also find that there was a paper recently that said, practitioners or people just in generally think that they're getting more done with AI, and that may be a mirage. So we don't really, again, these are just there's so much we don't know out here in the real world. And that's what matters, right? Especially as we're extending AI into everywhere, into the classroom, into healthcare settings. And what people don't want to hear is, well, you should check all the output, right? Like, we're going to put AI in your hands to make it easier for you, but it's on you to do all the work. So, what value is it bringing? And all of that requires a different type of evaluation methods, not ones that look at the model or even just the system in the real world context. And so what our work that Dr. Waters had alluded to at NIST with the ARIA program was designed to do that, and it is doing that. So how do these things show up? How do you get real feedback from end users that is more than just surveys, but what value and utility is it bringing in setting? So unfortunately, we don't have any really easy answers because we don't have that ecosystem set up.
Thank you. Good morning. Thank you for the presentation. So you raised an interesting point near the end of the presentation where you talked about the role of, I think you said sociologists and etnographers. So I think social scientists generally in evals, but broadly speaking, understanding systemic impacts of these models. So I think one of the issues to consider is the power of different disciplines within academia and the prominence that's given to computer scientists and engineers in AI development over everyone else. And that informs funders as well and government. So if we were to try and implement or reverse the direction that you had in your last chart, what could we practically do to convince people, funders, academic, university presidents, others, that there's actually a very important role here for people outside of computer science engineering?
Yeah, it's a question I get asked a lot. And having been a social science for my whole career, social scientist in the world of computer scientists, I will share it is not easy to tell computer scientists and engineers that, hey, we have value too. And they're like, whatever, it's too small. And so a lot of the kind of distrust or not excitement of working with social science is that it seems as slowing people down, and it's going to make it simpler and like just 30 people at a time. We proved in the ARIA program that that's not true at all. We can deploy a evaluation paradigm for thousands of people and give you real world, real life, randomized control trial evidence of what happens when your system is deployed in the real world. I think what that takes is not, I think it's important to recognize that interdisciplinarity is not just bringing, different types of people. We have to all understand each other and recognize that, we each bring value. That means that social scientists also need probably to know a lot, a little bit more about machine learning. And machine learning researchers also need to know a little bit more about social science. So that it's not easy. Interdisciplinarity is one of those things that it either takes hold, there's a spark and everybody gets it, or everybody hates it. They wants to talk to each other. So I think finding the right people to create a model, a pilot for this is how we do this, and then show the success, then that can help others. But I think kind of just bringing in one social scientist, and saying like, you're going to be this, person who we go to ask social science things is not a effective way to operationalize that.
We have time for one more question, if there is one. Okay, we are left speechless. That's not bad. Thank you very much. Thank you.